This is an overview of DDC1, Deck Decompression Chamber 1, here at Santa Barbara City College in the Marine Tech program. We have two 54-inch chambers, DDC1, and then over here in the background, DDC2. Both of the chambers are quite similar, but they have some significant differences which you need to be aware of, and that's what we're going to go through here in the corresponding video. Okay, let's quickly take an overview of the components on the outside of the chamber. Right here is your communicator or radio. It's a standard Amron two-diver radio made for a hyperbaric environment. It has an external microphone for pushing to talk. We have a timer or a stopwatch. It gives us the actual time of day, and then we can press this large button here and we can get the stopwatch to start, press again to stop, and then press down here in the lower right to clear it. These are your pneumathometer gauges for the inner lock and for the outer lock, and that tells you your depth of the chamber. Now, it's very important for us to note that these depth increments here are in 2-foot divisions. So when you are reading this depth gauge, you need to understand that each one of those marks is 2 feet versus DDC2, they are 1-foot increments. And when that becomes particularly important on our ascents, so that we're maintaining a proper ascent rate prescribed by the U.S. Navy. So we have our gauges, we have our timer. We also have a TV camera inside this chamber, and this monitors the occupants inside the inner lock. And here is the camera itself. The viewport is blanked off and the camera is kept inside. This is your power junction box to supply the chamber. This switch right here simply turns the power on and off in the chamber. So to turn the chamber off, that turns off all of the power to all of the devices. We do not need to shut down each individual switch on the chamber. For example, the camera, the monitor, the radio, etc., and the lights. So we want to leave that switch in the up position when we're operating, and that gives us power. And your radio is already on, and you're pretty much set to go. The device right here is a device that we use here on DDC1 to monitor our ventilation rates. This is a flow meter, and this flow meter is calibrated in standard cubic foot per minute. It tells us how much standard cubic foot per minute of air we're moving through the chamber when we're ventilating. There is a small aluminum ring here you can see, and this ring rises up to match the corresponding number and tells us how many standard cubic foot per minute we are venting. You are not going to see these out in the commercial diving industry, simply because we will vent as much as we can for about 15 to 30 seconds, depending upon the number of occupants and the depth. The U.S. Navy manual has prescribed ventilation rates for divers breathing oxygen, tenders breathing oxygen, etc. And we will run through that so that you have a understanding of how many standard cubic foot per minute minimum we need to have. So we do interrupted vents, and our general rule is to vent as much as we can for about 30 seconds. If you do that once every 5 minutes, you will not have a problem with carbon dioxide, and you should not have a problem with oxygen leaking into the environment or oxygen content raising above 22, 23%. 23% is our max. So when we get to 22, 22.5%, we start ventilating regardless of what the time frame is. We want to kick that oxygen percentage down. So this exhaust air flows out through this PVC piping, and it goes out through a small hole that is discharging the gas outside the building. It's a little bit quieter this way as well. DDC1 is also equipped with a med lock. This is unique to this chamber. You may see some IMCA certified chambers that have a med lock. We use this device right here to transfer small items in and out during a treatment or during a chamber run. And it's very simple to operate. It runs off of the internal chamber air. There is a ball valve on the inside of the chamber on the other side of this penetrator. That valve must be opened. That gives us access to the gas, the pressure from inside the chamber. So if we're at 60 feet, we'd have 30 psi of gas in the chamber, I would then open this valve. This valve would allow gas to come through, down through this piece of tubing here, and then it goes up inside the bottom of the lock and would pressurize the lock. It's important for us to notice that this lock, this med lock, is an external sealing hatch. That's why we have these dogs here that holds the hatch shut. Obviously these must be in place and sealed down, and there's an O-ring right inside here that seals this door. So all these dogs must be closed in place. This just takes seconds to pressurize. We open this valve. Once it equalizes, the occupants on the inside can open a corresponding hatch on the opposite side here. It's held together with some small stainless steel dogs in the inside. We'll look at that in a minute. They would then open the door, remove whatever device they're taking out, whether it be a urine bottle, it could be an IV kit, could be anything. They'll remove that object out, and then they'll close their valve and shut the door. At that point there, I'm ready to bring the bed lock back to the surface. I close my supply valve, and then I simply verify on the radio with the operator that that door is shut and it is sealed, and then we would exhaust or open this valve, and that will vent the gas from inside this lock out here. So simply exhaust the gas out. This gauge will return to 0. Then we can open the dogs. And when we're ready to put another object in there, we'll close that valve and start the whole process all over again. Got the gas supply for the chamber. There are 2 Quincy 5120s down in the compressor room that feed the air system in the Marine Tech building, and this is one access valve. It is a quarter turn ball valve. It's shut right now, so we'll open that, and that's going to give us pressure down through this soft line here. It goes under a trip tray. This stays hooked up and in place at all times. So this hose moves under the chamber, and it ultimately ends up right down here at this manifold, and there's a shut-off valve right there. There's also a check valve right here. This check valve is a very important device that must be installed on all chambers. In case that line were to be cut, that deck whip gets cut or nicked or squashed, we would lose chamber depth. And in many operations, you could have your deck whip running a significant distance away from your chamber over to the compressor. So if you were losing gas, you'd be relying on that check valve to maintain your depth. So if that valve is open, it comes up into an air manifold here. And unique to both of our chambers here at Marine Tech is the fact that we have inside controls and outside controls. So you'll see this large manifold here. It branches off left or right and goes to some ball valves which are taped in the open position. The reason they are taped open is because this is the supply for the inside controls. So we leave those valves open. The corresponding valves on the opposite sides of those are in the closed position, and they're taped shut. So we only want to use those when, and it's rare that we do this, that we want to have the operator, the diver inside control the chamber. But the vast majority of chambers you're going to encounter in the commercial diving industry are not going to have these dual controls. Our air comes up to our main controls, and these are really the valves you need to be concerned about. There's a valve on the left that supplies the inner lock, and then there's a valve on the right that supplies the outer lock. If you come up a little bit higher, you'll see there's exhaust valves. Right here, this is your exhaust valve. It's a quarter turn ball valve. That's the exhaust for the inner lock. And then over to the right here is the outer lock exhaust. So if you look, these valves are plumbed together. They're manifolded together down through this piece of stainless steel pipe and goes into some copper piping and connects over to the inner lock. Now, if you follow that line up, it leads up through our flow meter. So regardless of which valve you're opening, it's going to exhaust gas down to that common manifold and then out the side of the building. So if you want to test the air pressure here, this will tell you what the compressor pressure is set at. And this looks like it's right around 170 psi here. I open my You can hear the gas flowing on the inside. Gas to the airlock. So, in essence, the chamber is set up and ready to be pressurized. All the valves are shut for supply and exhaust. And let's take a look at the valves on the inside.